Hi there, Tom Mitchell here, founder of labitpro.com. In this Microsoft Azure tutorial for beginners, what we're going to do is walk through the core concepts you need to understand if you're just getting started with Azure or with cloud computing in general. We'll start by looking at why cloud computing really matters, what cloud computing actually is, and what Microsoft Azure brings to the table. Then we'll dive into some of Azure's major categories of services, those being compute, networking, and storage. And we'll explore some of the services that you'll use most often when building real-world solutions. Now, before we jump into Azure itself, let's talk about cloud computing and why it's become so central to everything we do in the technology vertical. I want you to imagine that you've come up with some kind of cool idea for a brand new web application. Something that people are going to really love, something with a smooth user experience and the potential to make lots of money. To bring that idea to life, you need servers, you need storage, networking infrastructure, developers, test environments, you need load balancers, you need security, and probably several other components depending on what the application does. Each of those pieces costs time, it costs money, and requires effort to procure, configure, and maintain. Now, traditionally, if you wanted to launch an online application like this, you had to buy physical servers, you had to install them in a data center, you had to set up network connectivity, configure firewalls, and essentially prepare everything in advance. And you needed to guess how big the systems needed to be, because if the application suddenly became popular, you wouldn't be able to scale fast enough. Now, on the other hand, if the application didn't take off, you'd be stuck with a major financial loss from the upfront investment. That's the problem cloud computing solves. It allows you to use compute resources over the internet without owning any hardware. You pay only for what you actually use, and you scale up or down whenever you need to. So when you hear the term cloud, think of extremely large, heavily secured data centers filled with thousands of servers, storage clusters, networking gear, and all the services required to power modern applications. Companies like Microsoft invest billions into building and maintaining these global data centers, and they expose the computing power inside them through platforms like Azure. When you use a cloud service, whether it's running a virtual machine or uploading a file, hosting a website, or processing data, you're simply connecting to one of these massive data centers through the internet. You don't buy the hardware. You don't install the operating system. You don't patch anything. You just use the service and you're billed based on your consumption. Cloud computing is used everywhere today. Platforms like Netflix stream content directly from cloud infrastructure. Machine learning workloads run on cloud GPUs. Websites, mobile apps, APIs, and business systems run on cloud resources because companies no longer want to manage physical hardware. Developers love cloud services because they can spin up new environments in minutes, test ideas quickly, and release features faster. And IT professionals like us appreciate cloud platforms because they simplify infrastructure management dramatically. Now let's shift our focus to Microsoft Azure. Now, Azure is Microsoft's cloud computing platform, and it's one of the most widely used cloud platforms in the world. Hundreds of services run under the Azure umbrella. Everything from virtual machines and serverless functions to machine learning platforms, databases, networking tools. You have security services and storage systems, and a whole lot more. Azure provides the same capabilities you'd find in a traditional data center: server, storage, networking, and security, but everything is available on demand. You just log into the Azure portal, choose the service you want, configure it, and then Azure provisions it for you in whichever region you select. Azure has grown rapidly because of its breadth of features, because of its integration with the Microsoft ecosystem, and because of its global presence. As a matter of fact, Microsoft operates dozens of data center regions worldwide, and each region contains multiple facilities to provide redundancy. So when you deploy a resource in Azure, you choose the region where it's going to live, and then Azure handles the rest. This allows you to place your applications close to your users, which improves performance and availability. So now that we've covered the foundation, Let's dive into some of the core Azure service categories. We obviously can't cover every single category because we'd be here all day, but we are going to cover the basics here. We'll start with compute, because compute resources really do form the heart of most Azure deployments. Whether you're running a workload or hosting a website, deploying an API, or building a backend for a mobile app, you'll rely heavily on Azure's compute services. Now, the most fundamental compute service in Azure is the virtual machine. An Azure virtual machine lets you run Windows or Linux operating systems on cloud-based hardware that's managed by Microsoft. When you create a VM in Azure, you choose the region you want to deploy to, the size, which refers to the CPU and memory. You select the disk type and the network settings. Azure handles the provisioning, the storage, the networking, and the hypervisor layer. You're responsible for the operating system and anything you install on it. This is ideal for workloads that require full control of the environment. Think of things like domain controllers, legacy apps, line of business applications, or anything that would typically require a traditional server. Now, what makes Azure virtual machines especially powerful is the ability to scale them on demand. This means you're not locked into a single size. So if your application needs more power, you can resize the VM to give it more CPU or memory. If the workload quiets down, you can scale it back or even shut it off to save money. And Azure provides multiple disk performance tiers, so you can support everything from basic workloads to high throughput enterprise applications. Now, while virtual machines give you full control, some applications need to scale automatically based on demand. And that's where Azure Virtual Machine scale sets come into play. What a scale set does is allow you to deploy a group of identical VMs behind a load balancer. And then what Azure does is automatically increase or decrease the number of instances based on rules that you define. So if your website starts receiving more traffic than usual, the scale set adds more VMs. Once that traffic slows down, the scale set automatically scales back. Obviously, this is ideal for stateless applications, microservices, or workloads that experience significant fluctuations in usage. Now, if you prefer to not manage VMs at all, Azure offers the App Service. Now, what the App Service is a fully managed hosting platform. It's for web applications, APIs, and mobile backends. With App Service, you deploy your code, and then Azure takes care of the runtime environment. It handles the scaling, patching, and security updates. It's perfect for developers who rather focus on application logic rather than operating systems. You can deploy apps built with .NET, Node.js, Python, Java, PHP, and more. Built-in features like custom domains, SSL certificates, authentication, and deployment slots make App Service extremely powerful while keeping management simple. In addition to these compute resources, Azure also provides Azure Virtual Desktop. Now, what this is Microsoft's cloud-based VDI solution, or Virtual Desktop Infrastructure solution. Azure Virtual Desktop allows you to publish full Windows desktops or individual applications to your users. And you can do this regardless of where those users are located. The desktops run in Azure, and then users connect securely from their laptops or even tablets for that matter, pretty much almost any device. This is ideal for remote work scenarios, application virtualization, and organizations that want centralized management of user environments without building on-prem VDI infrastructure. Now, all these compute services play specific roles. For example, virtual machines give you full control, scale sets give you elasticity, App Service gives you managed hosting, and Azure Virtual Desktop gives you cloud-hosted user workspaces. Together, they form a flexible compute ecosystem that allows you to run almost any workload in Azure. Now let's move into networking, which essentially ties everything together. Every resource in Azure needs networking, whether it's a VM, an app service, a function, or even a storage account for that matter. And Azure's networking services allow you to build secure, flexible, high-performance environments that rival traditional enterprise networks. At the center of Azure networking is the Azure Virtual Network. An Azure Virtual Network, or VNet, is essentially your private network in Azure. It's isolated from the internet unless you choose to expose something externally. When you create a VNet in Azure, what you're doing is defining the IP address space, you create subnets, and then you deploy your resources inside the VNet. Now, virtual networks behave like traditional networks. They support routing, segmentation, private IP addressing, DNS, and security controls. A VNet is where your VMs live, it's where your application tiers communicate, and where your services interact securely. Now, to control traffic inside your virtual networks, Azure provides what's called network security groups, or NSGs. An NSG acts kind of like a cloud-based firewall that you attach to a subnet or a network interface. It contains inbound and outbound rules that allow or deny traffic based on protocol, port, and source or destination. What NSGs do is give you granular control over how your resources communicate with each other and with the outside world. You can lock down a subnet to only specific types of traffic that are allowed, improving your security posture significantly. Now, sometimes you're going to need to connect virtual networks together, either within the same region or maybe across different regions. Azure allows you to do this through the use of VNet peering. When two networks are peered, traffic between them flows through Azure's backbone network with extremely low latency. What peering does is essentially make two VNets act like one, while still allowing you to keep their address spaces and subnets separate. As you'd expect, this is useful for connecting like development and production environments, linking separate workloads, or building multi-region architectures. Another service that plays a major role in secure connectivity is Azure Bastion. Azure Bastion allows you to connect to your virtual machines securely through the Azure portal without exposing RDP or SSH ports to the internet. Instead of opening ports like 3389 or 22, which obviously increase the attack surface, what Bastion does is provide a fully managed, hardened environment for remote access. You simply click Connect in the portal, and then Azure opens an in-browser session to your VM over a secure channel. This greatly reduces security risks and is really considered a best practice. Azure also offers Azure Load Balancer. Now, what this does is distribute incoming traffic across multiple virtual machines or instances of an application. If you're running a web application or any service that needs to remain available even if one server fails, a load balancer ensures smooth distribution of traffic. It works at layer 4 of the OSI model and is perfect for high performance, low latency workloads. It's commonly used with scale sets, multi-VM deployments, and highly available architectures. Now, on a global scale, Azure provides Azure Traffic Manager. Now, this service routes user requests to the best performing or geographically closest endpoint using DNS-based load balancing. It helps ensure that users are directed to the fastest available location, and it also provides failover between regions. So if your application is deployed in multiple Azure regions, Traffic Manager can automatically route users to another region if one becomes unavailable. This helps achieve global high availability and it improves performance for users around the world. So together, Azure's networking services allow you to build secure, scalable, multi-tiered architectures that can span multiple regions and support complex enterprise workloads. The virtual networks give you the foundation. The NSGs, or network security groups, secure the traffic. VNet peering expands your infrastructure. Bastion secures your access. Load Balancer distributes your workloads. And Traffic Manager extends your solution across the globe. Now let's take a look at Azure Storage Services. Now, storage is one of the core parts of any cloud solution because applications need to save, They need to retrieve and they need to manage data. Azure provides multiple storage options to support everything from simple file storage to massive unstructured data to high performance disks and more. Everything starts with the Azure storage account. Now, a storage account is a logical container that's used to store your blobs, your files, queues, tables, and disks. When you create a storage account, you choose parameters like performance tier, which would be standard or premium. You select a redundancy option like LRS or ZRS or GRS, and you configure the access settings. All the data services within that storage account inherit these settings. The storage account is essentially the wrapper that organizes and manages your data services. One of the most widely used storage services inside a storage account is Azure Files. Now, what Azure Files does is provide a fully managed file share system that you can access over the SMB or NFS protocols. If you're used to traditional file servers or shared network drives in an on-prem environment, Azure Files gives you a cloud-based version of the same experience. Applications can mount these file shares from anywhere, making it ideal for lift and shift scenarios where you need shared storage without deploying a full server. Azure Files can also be integrated with Microsoft Entra ID for identity-based access control. Another major service is Azure Blob Storage. Now, what Blob Storage does is allow you to hold massive amounts of unstructured data. Think things like images and videos, log files, documents, backups, data lakes, all that stuff. These blobs are optimized for scalability and cost efficiency, and they support multiple access tiers so you can store your frequently accessed data in the hot tier and then move your rarely accessed data into cool or archive tiers to save money. Many cloud-native applications use blob storage for content delivery, things like analytics and long-term data retention. Now, when you deploy virtual machines, you'll rely on another type of storage, and that's Azure Disk Storage. Now, disks in Azure come in several performance tiers, ranging from standard HDD for low-cost workloads to premium SSD and UltraDisk for high-performance enterprise scenarios. These disks provide durable, high-throughput storage for your virtual machines and for stateful applications. Azure manages the replication and durability of the disks behind the scenes so that your data remains safe even if hardware fails. Together, these storage services provide Azure with the flexibility to support virtually any type of data workload, whether you're storing application files, hosting user documents, saving virtual machine data, or building large-scale analytics systems. Azure's storage offerings provide the performance, the durability, and the scalability that you'll often need. So at this point, we've covered the foundational components of Azure, compute, networking, and storage, as well as the role of cloud computing and what makes Azure so powerful. But the real value comes when you bring these services together to build solutions. For example, a typical application in Azure might use virtual machines or app service on the compute side, connect them through a virtual network with network security groups for security. They'll rely on VNet peering to communicate between environments, maybe use a load balancer for high availability, and then store the application data inside Blob Storage or Azure Files or on managed disks. For global applications, Traffic Manager helps distribute traffic, and Bastion secures administrative access. This combination of services provides everything you need to build resilient, scalable, enterprise-grade applications without ever touching physical hardware. And because everything in Azure is pay-as-you-go, you maintain incredible flexibility while controlling costs. As you continue learning about Azure, you'll discover hundreds of additional services, but the ones we covered today are foundational. If you understand these core components, you'll be better prepared to explore more advanced areas like databases, identity, analytics, DevOps, AI, and more. So thank you for joining me in this Microsoft Azure tutorial for beginners. I hope this helps you build the confidence and understanding you need to take your next steps in Azure. If you found this useful, be sure to like and subscribe, and also be sure to visit labapro.com, where you can practice real-world hands-on Azure exercises via my lab simulations.